Okay, so 4.4, counting. We are on page 169. Okay, so there is the multiplication counting rule for a sequence of events in which the first event can occur n1 ways, and the second one can occur n2 ways, and the third event can happen n3 ways, and so on. The total number of outcomes is nothing more than multiplying it, right? So this is kind of like you're at your favorite pizza place, right? And you can have, I don't know, how many different kinds of pizzas can you make, right? So if you're, let's say that you were at a pizza place and there were 3 different sizes, right? There are 3 different sizes. There are 10 different toppings. What else? What other choices do I have here in the pizza place?
Stuffed crust.
Stuffed crust. So crust. Okay. Crust. We'll say there's stuffed crust, regular crust, and what?
Garlic. Thin and garlic.
Thin and garlic. Okay, there are 3 different types of crust. What else? Huh? Sauce. Okay, how many different types of sauce?
Like tomato.
Do you like mozzarella sauce? Some people do barbecue. White sauce.
So there's white, pesto, and red, right? White, pesto, and red. Right.
Why do they do like a vegan one too? That's probably.
Well, that would be the crust, right? That would be a different kind of crust, I'm assuming. Right? What else?
Like
To go or here, right? To go or here.
tip or no tip.
Tip or no tip. So how many different kinds can we get?
A lot of them.
2 times 3 times 10 times crust times sauce. That many, right? Okay. This is what they're saying with the multiplication rule, right? Because every single one of them, you can have different ones, right? Correct? Okay. Correct. Okay, so let's do example number 1. When making random guesses for an unknown 4-digit passcode, each digit can be 0 to 9. What is the total number of different possible passcodes? How many are there? So I can have 4 different numbers, right? 1, 2, 3, 4. How many different choices here? Correct? You're just multiplying it all the way through, right? 1 in 10,000, right? A lot of guesses to try to guess that one. Okay, so the factorial rule. What's a factorial? You guys heard of a factorial before?
No.
You've never heard of a factorial? So, definition of a factorial is that if I have 5 factorial is the same as 5 times 4 times 3 times 2 times. So that is a factorial. So if I did this out, what would I get? This would be 20 times 6. 5 factorial is 120. Okay, 120. If I had anyway, so that's factorial rule. So the factorial symbol denotes a product of decreasing positive whole numbers. Okay, so we just did that. And by the way, 0 factorial by definition is 1. Factorial rule, number of different arrangements where the order matters of n different items when n of them are selected is n factorial. So in other words, let's say that I had 5 different I don't know, 5 different people, right? And I'm going to put them in order. And I'm going to make them a line, right? So if I have 5 different people, A, B, C, D, and E, right? How many different arrangements can I get? So how many different choices do I have in the first one? 5, right? But then I used one, correct? Oops. I used one. So how many do I have in the next one? 4. 4, correct? The next one would be 3, 2, and 1. You see that?
Mm-hmm.
Do you see where you would use this symbol here? 5 factorial? Okay, this is what factorial is, okay? All right. So let's say, we're example number 2, assistant researcher must personally visit the presidents of the Gallup, Nielsen, Harris, Pew, and Zogby polling companies. There are 5 different polling companies. How many different travel itineraries are possible? Right here, same thing that we just did, right? Because the order matters, correct? The order in which I go matters, right? It's not that we're just going to 5 different places. In what order am I going to? That's why the travel itinerary would be different, correct? B, if the itinerary is randomly selected, what is the probability that the presidents are visited in order from youngest to oldest? Well, there's only one way to be youngest to oldest, correct? Out of the 120, so it'll be 1 out of 120, correct? Does that make sense? Okay, so permutation and combinations. Permutation and combinations, okay, so when the order matters, they're called permutations. When the order does not matter, it's called combinations. So if I have 5 different people here, and I am choosing 3 people, okay, if I want to choose 3 people, okay, I would call that 5 choose 3, 5 combination 3. If I am picking 3 people to be the president, vice president, and treasury, or treasurer, I guess, right? Then would the order matter at that time? The order matters, correct? Because the first one would be the president, second one would be whatever the other one, right? So that would be 5 permutation 3. Totally different thing. So the way this works is this. The equation that we're going to learn is this, n factorial over n minus r factorial, and then permutation is n factorial over n minus r factorial. Now let's look at this. What's the difference here? What's the difference between these two? It's this guy right here, right? Everything else is the same. This guy has this. So you're dividing the number of combinations by another number, which means that this number is going to be larger or this number is going to be larger. Let's actually do this. So if I had 5, right here, right? So 5 choose 3 would be 5 factorial over 5 minus 3, and then 3 factorial, right? Whereas this one will be 5 factorial over 2 factorial, correct? Because I'm just putting in this equation right here, right? N minus r is 2 factorial, right? R factorial is just this right here, so 3 factorial. 5, 4, 3, 2. This would be 2 times 1. This would be 3 times 2. 5, 4, 3, 2, 2, 1. Correct? So, these two cancel out. 20 divided by 2 is 10. This guy and this guy cancels out. 60. There are more of these than these. Does that make sense? So I'm choosing 3 from the 5, right? Whereas this guy, the order matters, and this guy, the order doesn't really matter, right? In other words, if I picked 3 here, and it was A, B, and C. Now I picked 3 here, it was B, C, and A. It'd be the same thing. because the order matters here, order does not matter, right? There are several different ones that are considered to be the same here, which is why I have 60 here, only have 10 here. Okay? All right, so that's that. And let me see, how far am I supposed to go here today? One, two, three. Okay, so let's do example number 3. In a horse race, a trifecta. Anybody been to a racetrack before with their parents? You have? All right, so a trifecta is when you guess the win, place, and show. Right? Win, place, and show. First, second, and third. When you pick the exact order, it's called a trifecta. It pays the most because it's obviously the hardest, right? Because you have to pick the 3 horses and you have to pick the order. Okay? So, there are 19 horses. How many different trifecta bets are possible? So, was it this guy or is it this guy? Does the order matter here?
Yeah.
Order matters. So, which one is it? It's the bottom one, correct? So, we're going 19, 3. So, it'll be 19 factorial over 16 factorial, 3 factorial. N minus R, right? 19 minus 3 is 16. So this is the same as 19 times 18 times 17 over 3 times 2. Everybody see what I did there?
Wait, I thought you didn't do the thing on the permutation.
Oh, I do not. I'm sorry. You're right. So that's the answer. We already see that? You see what I did there? Because there's 16 blah 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 all the way down here, right? But they cancel out with the 16 down here, blah 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 blah. And all these are going to cancel out, right? I just got lazy and didn't write them all. 19 times 18 times 17, correct? Okay, so that's that. And then if you did that, it's 5,814. B, if a bettor randomly selects 3 of the horses for a trifecta bet, what is the probability of winning by selecting California Chrome to win, whatever, and whatever? Okay, so what would it be? Just 1 over this many, correct? 1 over that, right? Okay, so that's do all of the different possible trifecta bets have the same chance of winning? Do they have the same chance of winning?
Yeah. 1.
They won that one, right? Okay. Okay, we'll stop right there. And your homework for today is 5 through 15.